Back in 2017, NASA did something that seemed a bit shocking, maybe, because they crashed the Cassini space probe straight into Saturn. On purpose, they did that. And I remember thinking at that time, well, why would they destroy something so advanced, something so expensive? I mean, couldn't they have just left the space probe orbiting Saturn forever? Yeah, but no, they chose to end the mission with a fiery dive into the planet's atmosphere. And what's the reason why they've done that? Well, surprisingly, these are microorganisms. So hi, hello and welcome again, Microbehunter here, I'm Oliver. And in this channel we take a closer look at the hidden world of microbes. Well, today we're heading off planet to figure out what the bacteria had to do with NASA's decision to crash a, well, I guess billion-dollar spacecraft into the gas giant of Saturn. Why not just let it keep orbiting and collecting data like with so many other space probes? Why go out in such a dramatic way? And let's find out here. A little bit of history. Cassini was launched way back in 1997. NASA sent it on a mission to explore Saturn, its rings, and all of those mysterious moons that they are there. And I remember that even at that time it was already a little bit of controversial situation because there were plutonium batteries on the space probe, so people were kind of worried. But that is an entirely different story. Well, and after a 7-year journey through the solar system, it finally arrived in the year 2004. And then for the next 13 years until 2017, for the next 13 years, it orbited Saturn. It was sending back really nice images and data. It gives a really basically a front seat view of the Saturn's atmosphere. It revealed the intricate structure of the rings of Saturn and even spotted water ice plumes shooting out of some of one moon there, which is so difficult to pronounce that I'm not even going to try it. Yeah, it also used radar to map the surface of Titan, also one of the Saturn's, which is Saturn's largest moon. And Cassini didn't just explore it, completely reshaped what we know about the distant world, and it raised some big questions also about the possibility of life on those icy moons. So why did they choose crashing it into Saturn and burning it up this way? Well, in 2017, when the mission was wrapping up, NASA made a bold call. Let's send Cassini diving straight into Saturn's atmosphere and let's burn it up completely. And this wasn't just for dramatic effect. It was actually a very calculated move. And Saturn is a gas giant, so there is no solid surface to crash it on. So the probe was guaranteed to burn up, which is exactly what they wanted. Now why? Well, because even the cleanest spacecraft built on Earth carries microorganisms like bacteria, spores of fungi. And these microorganisms are basically in the world all over the place, and they will also be present on the spacecraft therefore. And for this reason, the spacecraft is put together also in a very clean room to minimize the contamination by microorganisms. But you see, that's also not perfect. So but still, this doesn't answer the question of why do you want to destroy all of the microbes by burning it up as it enters the atmosphere. Because if Cassini had been left drifting around Saturn, then there would have been a real risk it could one day crash into one of the moons of Saturn. And these moons are potential habitats for life. So yeah, this moon again, which is called Enceladus, I hope I pronounced it correctly, has a hidden ocean beneath its icy shell, and crashing Cassini into it would have meant contaminating it with the microbes from Earth. And those moons are too small to have their own atmosphere, so Cassini would not have burned up in the process. And that's a problem. Well, actually two problems, because the first problem is if there is native life on those moons, then the microbes from Earth could invade and throw everything off. And we've already seen how invasive species disrupt ecosystems already here on Earth. Now imagine this on a planetary scale. And the second reason is that in future science could actually be messed up a little bit. Because what if we send a mission later to search for alien life, and what do we find there? Well, Earth's bacteria. And this kind of contamination could also therefore derail research for decades, maybe even centuries. And there's also an ethical side. What if microbial life already exists out there? Even if it's so simple, it might be fragile, and introducing life from Earth could ruin a natural ecosystem there that we haven't even begun to understand yet. So burning up Cassini wasn't just the end of the mission, but it was actually also about protecting the integrity of other worlds. And in space science, this is what they call planetary protection. And yeah, there are indeed different categories here as well. The one that I talked about was so-called forward contamination, which was kind of bringing Earth's microbes to other planets. But there's also something called backward contamination. I mean, could it not be possible that, without actually knowing it, that we're bringing alien microorganisms back to Earth? Well, actually, it's a little bit theoretical, but I mean, space agencies treat it quite seriously when, for example, missions return with samples, like, for example, from the moon. I mean, they're sealed up tightly, and the goal is well, to actually keep also bacteria from Earth out of that sample, but also, if there were potentially life in that sample, to keep that one also isolated and locked away. Yeah, so you might be wondering, well, I mean, meteorites, right? I mean, from space, they hit Earth all the time, right? Yeah, sure. But you see, any potential microorganisms that would be present in those rocks would actually be burned up during the entry into Earth's atmosphere. Spacecraft samples are a whole different story here. Well, it isn't just a NASA policy, it's actually apparently a part of international law, because the Outer Space Treaty of the year 1967 says that space missions must avoid harmful contamination of other bodies, celestial bodies. And what about when spacecraft are meant to land there and not crash or burn up? Well, let's think back at the Viking missions of Mars to the year in the 1970s even. NASA baked the whole landers, in an oven, literally for 112 degrees Celsius for 30 hours. Even the electronics were built to survive that heat. And it was meant to kill off any microorganisms that might be present on the space probe. Nowadays, spacecraft are built in ultra clean rooms, so engineers have to wear full bodysuits, not to protect themselves, but to keep their bacteria from getting on the equipment. For example, the Mars rovers like Curiosity and Perseverance, they were not fully sterilized, that they're too complicated for that, but they were still rigorously cleaned. And NASA even took samples from the space probes to check what microbes might be still on them. So that way, if anything kind of weird shows up on Mars, then at least we can trace it back from where it came from. So what's my take of the whole situation? Well, if we are ever gonna set up a permanent base on another planet, let's say Mars, well, then contamination is going to happen. Yeah, it's inevitable, because our bodies carry more microbial cells than we have human body cells. Yeah, so essentially we humans are already walking ecosystems. And honestly, I mean, it might even be a good thing to but to actually bring along our microorganisms, because if we want to make Mars livable, then we need the microorganisms, because they're essential for breaking down waste, for recycling nutrients, and for kind of laying the foundation of an ecosystem. Microbes won't just follow us into space, but they actually are necessary for our own survival. Yeah, that's all I would like to share with you today. I would like to hear your view of this. Thank you for watching. Hope you enjoyed the video. Yeah, there's this like and subscribe button somewhere around here, for some more microbe science. Happy microbe hunting. See you around in the next video. Bye-bye.